We know that the germination rate of a particular seed is 60%. It is thought that the germination rate may be increased by use of a new fertilizer. 20 seeds are planted. State the null and alternative hypotheses for the test. So H0 is always the situation of no change. So we'll have P is equal to 0.6. Since we think that our new fertilizer might increase this, the alternative hypothesis would be that P is more than 0.6. We now want to define the critical regions for a test. We want to do 10% level, 5% level, and state the actual significance level. Now, we'll do it using that P is 0.6. Now, this is going to be a binomial distribution. The number of seeds that germinate is binomial with 20 trials and a probability of success of 0.6. So I need to look for my region, and on this calculator I'll go for a binomial CDF. Let's try something like 15 to 20 with 20 trials, probability of success 0.6, and that gives me 0.125. So that's too big. So let's go for 16. And this one works. That's less than 10%. So for my 10% test, my critical region is going to be from 16 upwards, and the actual significance is what we can see from the calculator here, about 1.5%. With discrete distributions, you're going to find it very rare that you'll get exactly 10%. Let's see what happens if I go up to 17, and that's now less than 5%. So for my 5% test, the critical region is going to start at 17, so 17 and upwards, and the actual significance I can read from the calculator is at about 1.6%. Now in part C, we're asked just to look at the 5% level, so that's this test here. What would be the conclusion if 15 seeds germinate? So 15 is in the acceptance region, and so we accept H0. However, if 17 seeds germinate, that's in the critical region, and we would say that there is evidence at the 5% level, or maybe we might mention the 1.6% level, to reject H0.